The autothrottle system is comprised of multiple line replaceable units, or LRUs, that work together to move the power levers according to your inputs. In this video, we'll discuss each component to give you an understanding of the autothrottle system. After this video, you'll be able to list the components of the autothrottle system and describe how they operate. Control of the autothrottle starts at the mode controller, located above the MFD. The autothrottle key engages, arms, or disconnects the autothrottle. The speed source switch is on the right side of the mode controller, along with the vertical mode controls. The autothrottle mode pairs with each flight director vertical mode according to specific system logic, which will be covered in the next video. The speed source switch has two positions: Flight Management System, or FMS, and Manual, or MAN. When the speed source switch is in manual, the speed knob can be used to select the airspeed reference for the autothrottle. Pushing in the speed knob changes the airspeed reference units between indicated airspeed and Mach. The speed knob adjusts the airspeed reference in 1 knot or Mach 0.01 increments. The speed knob can also be used to change the speed reference when FLC is the active vertical mode. The selected speed reference is displayed above the airspeed tape in cyan. When the speed source switch is in FMS, the autothrottle will follow the FMS targets defined on the flight plan FMS en route page. Targets are set for the climb, cruise, and descent phases of flight based on speed, torque, or ITT, and are either predefined or pilot-defined. The autothrottle system will set power to comply with the specific speed target for climbs and descents, or torque target for cruise, while respecting aircraft limitations. When targeting an FMS commanded airspeed, the FMS speed is displayed above the airspeed tape in magenta. A maximum allowable ITT limit can be set in 5-degree increments. If this limit is set below the standard max ITT, the autothrottle will limit engine power to maintain the selected ITT. In all phases of flight, the autothrottle will automatically manage power on both engines as necessary to protect against torque or ITT limit exceedance. While you can disconnect the autothrottle using the AT key on the mode controller, the primary means to disconnect the autothrottle is by using the AT disconnect switches on the power levers. The switches are ergonomically placed, so your fingers naturally rest on the switches when your hands are on the power levers. Power to the solenoid that engages the servo clutch travels through the AT disconnect switch. Pressing either switch will momentarily remove power from both servo solenoids and disengage the clutch, disconnecting the autothrottle. The autothrottle system uses two independent servos to move the left and right power levers. The servos are located in the center pedestal and attached to the power lever control cables via a push rod. The servos can move the power levers from idle to max power. Autothrottle control does not include operations beyond the idle stop, in-ground fine, or reverse. Propeller control and condition levers are still your responsibility. One of the autothrottle system limitations is proper setting of the power lever friction locks, as the servos must overcome the friction locks. You must set them to the minimum friction setting required to maintain power lever position when the autothrottle is disconnected. Similar to the Garmin Autopilot, the servos for the autothrottle system should not be overpowered under normal operating conditions. If you want to take control of the power levers, you should disconnect the autothrottle by pressing one or both AT disconnect switches on the power levers or the AT key on the mode controller. The circuit breaker for the autothrottle servos is on the number 2 triple fed bus, in the bottom left-hand corner of the right-hand circuit breaker panel. Pulling this circuit breaker will remove power to the AT servos. The foundation of the autothrottle system is the Garmin Integrated Avionics Units, or GIAs. The GIAs receive engine data, ADAHRs, and AFCS inputs. They then interpret this information and send the appropriate commands to the autothrottle servos to move the power levers in accordance with flight director guidance, as in relation to airspeed, attitude, and altitude. It can be helpful to think of the GIA as setting pitch and power to achieve the desired performance. For example, if you set the automation to maintain an altitude of 16,500 feet and an airspeed of 160 knots, the GIA will determine the pitch and power settings required and move the flight controls and power levers accordingly.
You should now be familiar with the LRUs and other components that make up the King Air Autothrottle system, and be able to identify the components in the cockpit. In our next video, we'll discuss the controls and indications of the system, diving deep into the modes you should expect to see when operating the autothrottle.